Hi, everybody. In this slideshow, we are going to go over how to convert moles, mass, and particles for compounds and review some things that we have been doing yesterday, like naming the particles for an element compound that is molecular or ionic, and how to give your answers with right labels and the correct significant figures. So you want to have a calculator handy. We are going to do some calculating. And let's get started. So this is a review from yesterday. Remember, we had this yesterday. We learned about this mole concept, and that a mole is always equal to 6.02 times 10 to the 23rd of something, okay? If that something is an element, like aluminum, then we call the particles, remember, atoms. If that something is a molecular compound, let's say like carbon dioxide, then we call the particles molecules, okay? And if that something is an ionic compound, like salt, then we call the particles formula units, okay? So just like a dozen can be 12 of anything, a mole can be 6.02 times 10 to the 23rd of anything, and this is what we call the particles depending on what type of substance it is. Now, does anybody remember what is the special name that was given to this number right here? You recall that is Avogadro's number. So we use that number, Avogadro's number, to do some conversions. This would be a review of what we did in part one. We can look at our question and get our starting number, like 3.35 moles of carbon dioxide. Okay. And the only allowable abbreviation for moles is MOL. Can't use M. And we can convert between molecules and moles, or moles and molecules, in one step using this equality. We set up a factor label, okay? We have to put moles on the bottom so that it will divide out. We need our molecules label on the top because that's what we're trying to find, how many molecules. And then we have to put numbers in the top and bottom of our factor to make it equal. 1 mole is always equal to 6.02 times 10 to the 23rd molecules. When we multiply that, we want to take our answer and round it to 3 significant figures because 3.35 has 3 sig figs. And I got 2.02 times 10 to the 24th. And we got to put a label on it. The label should not only say what it is, like molecules, but what kind of substance or what identity of the substance, like carbon dioxide. So how is this next problem different? If you look at this one, this time we're starting with the particles instead of finding the particles. And this time we're finding the moles instead of starting with the moles. So basically, we're going to use the same factor, only we are going to have to switch it upside down because this time when we set up our factor, we need the particles to be on the bottom. Like here, if we have formula units of NaCl, we need that to be on the bottom. And we need the moles to be on the top. We're still going to use this same equality. 1 mole is equal to 6.02. I hate when that happens. 6.02 times 10 to the 23rd of the, there it goes again, of the particles. But let's see if I can, there we go. But notice that so that our units divide out, up here we started with moles, so we had to put moles on the bottom. Here we started with formula units, so we had to put formula units on the bottom. So up here, Avogadro's number went on the top because the particles were on the top. down here, Avogadro's number went on the bottom because the particles were on the bottom. So you really do have to pay attention to lining up your units so that they will divide out and filling in the top and bottom of the factors so that they are equal. So this time we had to divide by Avogadro's number, and I got 0.0294 moles of NaCl. And of course, you could write these answers like this could be 2.94 times 10 to the negative 2 moles of NaCl. And you could also write them, remember, using the E. You can do that instead of using the times 10 to the power. So if you remember, we did that yesterday, okay? Well, let's say that I have a beaker with 50 milliliters of water. Now, the density of water is 1 gram for every milliliter. So that means that I would have 50 grams of water in my beaker if I had 50 milliliters of water. And I want to know how many molecules of water that is. Now, those molecules are too small for me to count. There's also way too many of them, okay? Now, we know that a mole of water is equal to this many molecules. The problem is I don't know how many moles of water I have. I need a way to convert this 50 grams of water into moles. Now, yesterday we learned that for elements, you just use the atomic mass from the periodic table to convert the grams into moles. But for a compound, okay, we need to find what is called the molar mass instead of the atomic mass. And basically what we need to do is we need to write a formula and figure out what does our total formula weigh. Okay, so let's try it with this compound. We're going to come back to the water problem at the end of this presentation. So let's try this compound, magnesium nitrate. Now, first of all, if we write the formula, we need to know our ions. So magnesium is +2. I know that because it's an alkaline earth metal, and all of those make +2 cations. The nitrate, I look up on my ion chart because it's polyatomic. It has more than one atom. And I see that nitrate is NO3 - 1. So first we got to write the formula. I need 1 magnesium and I need 2 nitrates. So I have to put parentheses, and then when I erase that random line, I'm going to have to rewrite my 0. Yep. It's not a 0, it's an L, actually. So that's the formula for magnesium nitrate. Now, magnesium nitrate is made of 3 elements. We've got magnesium, we have nitrogen, and we have oxygen. What you have to do is look at the formula and tell how many of each are in a formula unit for that formula. Like there's 1 magnesium. See right here, there's no subscript, so that means 1. There are 2 nitrogens. Gosh darn it, I really am getting tired of those random lines. Okay. Oh, here we go. What did I? Oh, right here. There are 2 nitrogens. Look, there's 1 nitrogen, but then we have to double it because of the 2 outside of the parentheses. And then there are actually 6 oxygen. See, there's 3 oxygen times 2 because the parentheses tells us there's, double the oxygen. And so once you know how many of each element there are, you have to take them each times their atomic masses. So you do still need the periodic table to give you, their atomic masses. And then we have to subtotal each one. Oh my goodness. It was terrible today. I thought it was bad yesterday. It's even worse today. So 24, 2 times 24 is what? 28. And 6 times 16 is 96. And then you need a grand total of all of those. And when I add those up, I get 148 grams. That is equal to 1 mole of magnesium nitrate. So the 148, is called the molar mass. Okay? So go ahead. Why don't you pause this presentation and try writing the formula and finding the molar mass for the lead 2 hydroxide. Now we will figure that you paused and you tried this. Lead 2 is Pb plus 2. Hydroxide is OH minus 1. So when you write the formula, it's going to be PbOH2. We need 2 hydroxides for every 1 lead. So when we're finding the molar mass, we've got lead, oxygen, and hydrogen. There's 1 lead, there's 2 oxygen, and there's 2 hydrogen. Why? Because of the 2 outside of the parentheses. That doubles everything that's inside. Get the periodic table, get the mass of each one. So 207 is the lead. There's 32 grams worth of oxygen, and there's 2 grams worth of hydrogen for a total of 241 grams in 1 mole of the lead hydroxide. Now we can use that information to solve a problem. Remember, that info from the last slide was that 1 mole of lead hydroxide is equal to 241 grams. That gives us a conversion factor. Our question says, what is the mass of 2.5 moles of lead hydroxide? So we start with 2.5 moles. We set up the conversion factor. We need moles of lead hydroxide on the bottom. Oh goodness, that looks terrible. That was supposed to be a P. We need moles of that on the bottom, and we need grams of it on the top. And we've got that relationship right up here because we know that 1 mole is equal to 241 grams. So we can use that 1 mole is 241 grams to fill that in. And now we can see how our label divides out. Our new label is going to be grams of the lead hydroxide. That's good because we are looking for mass, and grams is a mass label. And we can multiply the 2.5 times the 241, and we get 603 grams of the lead 2 hydroxide. Now, hopefully, one of the things you see is why this is a one-step problem. Remember, we've been talking about how we've got particles, we've got moles, and we can interconvert those like we did in the very first slide using Avogadro's number. Oh my goodness. There we go. One step interconversion between particles and moles right there. And then yesterday, we were talking about how we can interconvert moles and mass of an element using one step. Well, this new information that we can add up the mass of a compound and that also is equal to a mole, that allows us in one step to convert between the moles and the mass. So we didn't even need to use Avogadro's number or the particles in this. We just needed one step to go from moles to the mass. Okay. So let's take a look at this. First of all, I want you to think, how many steps do I need? How many steps do I need? So we are starting with molecules, and we're trying to find mass. So if you're going back and you're thinking about the steps, remember, we can convert from molecules to moles, and then we can do another step to convert from moles to mass. Okay, so we are indeed going to need 2 steps. Convert from molecules to moles, and then from moles to mass. So we can get started doing that. We know that we're starting with 1.50 times 10 to the 24th molecules of sulfur trioxide, so SO3. We set up our first factor, and we're converting from molecules to moles. So the molecules have to go on the bottom, and the moles have to go on the top, because we want the molecule label to divide out. Remember, 1 mole has Avogadro's number of particles, and this is that's a 10. And we can see how our label will divide out, and that will give us an answer in moles. But I don't want to stop right there, because we're not looking for moles, we're looking for mass. I'm going to do another step right here to go from moles to mass. Now for that one, since this is a compound, sulfur trioxide, SO3, I need to do a little work. I need to come down here and say, okay, sulfur, there's 1, oxygen, there's 3. Now, eventually, you don't have to show me the work for this. I do have you showing me the work for this at first, so that I know that you know how to find them. But eventually, it becomes sort of like a side problem that you do. And sulfur weighs 32. Oxygen weighs 16. When you think about where do you get these numbers right here, remember, you guys know where you get them, right? You get them on the periodic table, and then you multiply through, get the 32 and the 48, and then you add these together, and you get 80 grams, which is equal to 1 mole of SO3. So now that gives us a conversion factor. We are trying to go from moles to mass. So I got to put the moles of SO3 on the bottom and the mass or grams of SO3 on the top. We know that there's 80 grams in 1 mole. Our moles of SO3 divide out, and the only label we are left with is grams of SO3. We have to take 1.50 times 10 to the 24th. We divide by 6.02 times 10 to the 23rd. We multiply by 80. And to 3 sig figs, we find out that this is 199 grams of sulfur trioxide. Now, in this problem, we're going from molecules to moles and moles to mass. But in that problem at the very beginning that we were doing, we said we had 50 grams of water, and we wanted to know how many molecules were in that beaker. Well, we can just reverse this process. We can go from mass to moles and from moles to molecules. We can indeed now come back to that, come back to that problem. It's a graduated cylinder, not a beaker. But we can come back to that problem, and we can absolutely work this out. Okay, we're starting with 50 grams of water. So we start with 50 grams of water. To convert from grams to moles, it's a compound. We need to know, what does it weigh? There's hydrogen and there's oxygen. 2 hydrogens, 1 oxygen. Each hydrogen weighs 1. Each oxygen weighs 16. This compound has a total of 18 grams in 1 mole. Remember, this is how much, when you get that grand total, that's how much is equal to 1 mole of that particular compound. Notice that we set it up so that our units would divide out. The grams of water divides out. If this question said how many moles, we'd be done. 50 divided by 18 would give us our answer in moles, but it says how many molecules. So we need another step to go from moles of water to molecules of water. And remember, that's where Avogadro's number comes in. 1 mole is equal to Avogadro's number of molecules. Now, again, it works out nice. Our moles divide out, and molecules of water is going to be the label on our answer. Okay. So molecules of water is our label. And to get our answer, we have to take the 50, divide by 18, and multiply by Avogadro's number. We have 1.67 times 10 to the 24th. Now, throughout this presentation, I hope you were pausing it and putting these numbers in your calculator and trying to get these answers. If you have any trouble with your calculator, that is something that you can absolutely see me, because I can help you with, your specific calculator. It's tough for me to give general guidelines because they're all a little bit different. But you want to practice this not only with this presentation, but with other practice problems that are assigned. And just remember some of the basic, rules about all this is that you have to make it so that your units divide out, right? And every time you set up a factor, the top and bottom of that factor have to be equal. 1 mole is always equal to the molar mass of a compound in grams. And 1 mole of a compound is always equal to Avogadro's number of molecules or formula units, depending on what kind of compound. And certainly, this could be top or bottom. You have to set it up so that your units divide out, and that dictates which thing goes on the top and which thing goes on the bottom. But good luck. Keep practicing your problems and see me if you have any questions.